we will start preparing the software for the integration of AFM and Raman. So first thing, we want to switch to external triggers. Okay, when we use the scan control, which is used for the AFM Raman, we have to switch to external triggers. Next thing is the substeps. Now the substeps are the ones what determine the speed of the scan when we use scan control with the analog system. Okay, now we're talking about the analog system. So for example, if we put here 10, so that means that the fastest scan is going to be 10 milliseconds per point, okay, per pixel. When we switch to external triggers, so we can't control here in the regular way the time per point. Okay, this is only, it can be done when we have the internal triggers. So with the external triggers, what dominates the speed is the scan substep. Okay, when we use a hybrid system, so there's no option of choosing between internal or external triggers. With a hybrid, it's always external triggers. What we have to do is to check this box here, use scan control. Okay, another important thing is the scan substeps, is that with a hybrid system, these substeps don't control the speed of the scan when we're using the scan control. So here you could put the maximum for the hybrid system, and that is 64 substeps. Okay, with a hybrid, we're not going to increase the substeps more than 64. That's the maximum value. And the speed of the scan, which when we're going to scan using AFM Raman, using the scan control, is controlled in the regular way right here. Okay, so now we're going to open the scan control. So we just press on scan control, and this window will open, the scan control window. So what do we see here? So first, the time per substep. Okay, so remember, let's say we put 10 substeps, so that means that 1 times 10, so that means that the time per pixel is going to be 10 milliseconds. With the hybrid system, there's no need to play with these parameters. Just set 1 for time per substep and don't worry about the calculation about time per pixel. Now we see in the scope area, in that purple area, all these white blinking dots. So those dots are the points where we're going to take the acquisition with the Raman. So we can press on empty measurements, and then we can create our own grid or decide where the points we want to have for the Raman acquisition. We can just press on add point and just add a single point if we want to add another point. So again, we have to press on add point. But we're going to use the more popular way, and that's the using the grid. And what's important before we choose the grid is to decide on the pixel spacing, because the grid is going to be a certain area, and inside that area we have to decide how many acquisitions port we're going to take. So we have a certain resolution which we already set before per line, for example 256 points per line, pixels per line. So every X amount of pixels, that's where we're going to have acquisition point. Now why don't we just choose all the pixels, let's say just set in the pixel spacing 1, because that's going to make our scan much slower. So we have to decide a number which makes a certain sense. A typical laser spot is about 1 micron in diameter. So to get a good spatial resolution of the Raman, okay, from the laser, that means like a half a micron. So we have to make sure that our pixel setting is, let's say, about every half a micron we're going to have an acquisition. So we have to remember we're doing here AFM Raman. We want to see a correlation between the AFM and the Raman. Okay, we're not looking to get here a better Raman resolution. Better Raman resolution is the terse. This is not our scope right now. In the purple area where we add the acquisitions point, so we see the y-axis in microns, that's the scan size, and the x-axis, that's pixels. Okay, we set, let's say, 256 pixels per line, so we see here double that number. That's because we have for trace and retrace. It's also possible to add acquisitions point on the retrace area, though we're going to use only the trace. Most people don't use the retrace option. We'll press on the grid button, and then we'll move our mouse to the purple area and press on the left side of the mouse, left click, and drag it to whatever area where we want the acquisitions to be. Now it doesn't have to be perfect, because the second we leave alone our finger from the left button of the mouse, so the following window will open. We don't have to worry so much about exactly where we pulled and dragged that grid, because here we're going to set the boundaries in a precise way. So here, for example, the left is going to set the left boundary, and this is going to be the upper boundary, and then we can also set the right and the lower boundary. Now when we say boundaries, so we mean for the left, let's say number 1 for left, so that means that that's the left column, so column number 1, that's going to be the left boundary, and for the right one, so that will be the right column, and then the upper, that's going to be the upper row, and for the bottom one, that's going to be the bottom row. Now it's important to note that here in this scan control, we count the pixels from 0 and on. So for example, if we have 256 pixels per line, okay, also in the slow axis, so our most upper boundary can be 255. Now it's recommended not to use the first or the last line for acquisitions points. So let's say you start from the bottom one as number 1 and the most upper one 254. We'll press OK, and then we'll see all the white dots. That's where we're going to take acquisition with the Raman. Now we have to choose in the software the specific measurement, the spectrometer which we're going to use. So in this case it's going to be Renishaw, and we see that it's not connected. That means there's no communication between the NWS and Wire software. So in order to initialize the first communication, mostly when you turn on both of the softwares, so first in the Wire program, you want to create a new acquisition. Okay, so you set up the parameters, and in this case also we're going to lower the intensity of the laser in order not to harm the tip. We're going to take an acquisition with the Raman just to make sure that everything is working on the spectrometer side and the laser side. Okay, so we'll just press like this round circle, which is going to take acquisition every other second. And of course we see here there's no signal because we have to change the microscope, switch it so the laser is going to be on the sample. And we see this peak of the silicon and also all that noise to the left of it. That's because we didn't turn off the lights, so we have to make sure to switch off the lights. And then we have to play with the focus in order to optimize the signal so we'll get the best signal. After we optimize the signal from the Raman, so we'll just create a new acquisition window just so we'll have all the data on a clean window and all the data on its own. So again, the same idea, we'll set the parameters. And now what's important is that we choose set a run remote measurement. Okay, so this is important. We'll see this window open. And now we'll go back to the scan control. And we'll go to the communication tab. And here we'll press this button here. And we'll have this window pop open. We'll press OK. This window means that before we're going to run an AFM Raman scan, we have to again press on Run Remote Measurement. Okay, because even though we have now the green light indicating that both of the softwares are connected, so before we run an AFM Raman scan, again we have to press on Run Remote Measurement. Okay, so always before an AFM Raman scan, we have to make sure that in Wire, this window is open in such a way. Before we're going to start the scan, we'll just make sure that the error is okay, that it's oscillating near the 0. And we don't press scan like in the regular way, but we go to the scan control, and just press on start, and then the scan will begin. So we can see in the regular window of NWS the scan beginning. And when it's going to reach the first acquisition point, it's going to stop and take an acquisition. So here we see the total number of triggers altogether we have. And right now we see which number trigger we're right now. And to the left we see that blue button flashing. That means that it's sending triggers to the Raman spectrometer. And right here we see the Raman data acquisition, which is taking right now. All of the data is being seen on one window, and at the end of the scan all the data will so in between the lines, at lines where there's no acquisitions point, we'll see this window on wire. And we can also use the opportunity to continue to optimize the AFM to increase the set point, play with the PID gains. So it will continue to take acquisitions until it's done taking the acquisitions, and the scan will also finish, and then it will stop just like in a regular AFM scan. So the scanner will stop, and then we can start analyzing offline all the data.